Can scipy's regular grid interpolator return both values and gradients with a single call? I'm using scipy.interpolate.regularGridInterpolator with method equals linear. Getting interpolated values is straightforward, see example at this URL. What is a good way of getting gradients along with interpolated values? One possibility is to call the interpolator multiple times and compute the gradient manually using finite differences. This feels wasteful given that each call to the interpolator is probably already computing the gradient under the hood. Is that correct? If so, how can I modify RegularGridInterpolator to return both the interpolated function value and its gradient? To be clear, I'm not interested in the true gradient of the function which I'm interpolating, just the gradient of the linear approximation, for example the gradient of my interpolating function in the example at this URL. Here is an example. I have a function f, I build a linear interpolator f_interp, and I am interested in the gradient of f_interp, as opposed to the gradient of f. I can compute it using finite differences, but is there a better way? I assume RegularGridInterpolator is already computing the gradient under the hood, and doing it fast. How can I modify it to return the gradient along with the interpolated values? Here's a picture of f and f_interp. I'm interested in the gradient of f_interp, solid lines.
No. Here is what scipy.interpolate.regularGridInterpolator does under the hood. This URL. It uses scipy.image.map_coordinates to do the linear interpolation. Coords contains the location in pixel coordinates. You should be able to use these weights, and the lower and upper values at each dimension to figure out how steep the interpolation rises. However, the gradient also depends on the values of the corner points. You can find the math here, this URL.
If you want to see more, please consider subscribing.